You're now on episode 11 of 15 in this AWS Certified Solutions Architect Associate SAA-C03 practice playlist. We'll continue with questions 101 through 110, one question at a time. Question 101. A company is planning to move its data to an Amazon S3 bucket. The data must be encrypted when it is stored in the S3 bucket. Additionally, the encryption key must be automatically rotated every year. Which solution will meet these requirements with the least operational overhead? Option A. Move the data to the S3 bucket. Use server-side encryption with Amazon S3 Managed Encryption Keys, SSCS3. Use the built-in key rotation behavior of SSCS3 encryption keys. Option B. Create an AWS Key Management Service, AWS KMS, Customer Managed Key. Enable automatic key rotation. Set the S3 bucket's default encryption behavior to use the Customer Managed KMS key. Move the data to the S3 bucket. Option C. Create an AWS Key Management Service, AWS KMS, Customer Managed Key. Set the S3 bucket's default encryption behavior to use the Customer Managed KMS key. Move the data to the S3 bucket. Manually rotate the KMS key every year. Option D. Encrypt the data with customer key material before moving the data to the S3 bucket. Create an AWS Key Management Service, AWS KMS, key without key material. Import the customer key material into the KMS key. Enable automatic key rotation. The correct answer is B. Create an AWS Key Management Service, AWS KMS, Customer Managed Key. Enable automatic key rotation. Set the S3 bucket's default encryption behavior to use the Customer Managed KMS key. Move the data to the S3 bucket. Explanation. A Customer Managed KMS key with automatic rotation gives full control and meets compliance with minimal operational effort. Why not option A? SSCS3. Keys are managed by AWS and do not support automatic rotation under user control. Why not option C? Manual KMS rotation adds unnecessary operational burden. Why not option D? Importing key material. Imported keys do not support automatic rotation. Question 102. The customers of a finance company request appointments with financial advisors by sending text messages. A web application that runs on Amazon EC2 instances accepts the appointment requests. The text messages are published to an Amazon Simple Queue service, Amazon SQS, queue through the web application. Another application that runs on EC2 instances then sends meeting invitations and meeting confirmation email messages to the customers. After successful scheduling, this application stores the meeting information in an Amazon DynamoDB database. As the company expands, customers report that their meeting invitations are taking longer to arrive. What should a solutions architect recommend to resolve this issue? Option A. Add a DynamoDB accelerator DAX cluster in front of the DynamoDB database. Option B. Add an Amazon API gateway API in front of the web application that accepts the appointment requests. Option C. Add an Amazon Cloud Front distribution. Set the origin as the web application that accepts the appointment requests. Option D. Add an auto-scaling group for the application that sends meeting invitations. Configure the auto-scaling group to scale based on the depth of the SQS queue. The correct answer is D. Add an auto-scaling group for the application that sends meeting invitations. Configure the auto-scaling group to scale based on the depth of the SQS queue. Explanation. Scaling the consumers based on queue depth ensures timely processing as volume increases. Why not option A? DAX speeds up read performance but doesn't affect email scheduling delays. Why not option B? API Gateway would front the web app but doesn't improve invitation processing speed. Why not option C? Cloud Front caches static content not relevant to backend message processing. Question 103. An online retail company has more than 50 million active customers and receives more than 25,000 orders each day. The company collects purchase data for customers and stores this data in Amazon S3. Additional customer data is stored in Amazon RDS. The company wants to make all the data available to various teams so that the teams can perform analytics. The solution must provide the ability to manage fine-grained permissions for the data and must minimize operational overhead. Option A. Migrate the purchase data to write directly to Amazon RDS. Use RDS access controls to limit access. Option B. Schedule an AWS Lambda function to periodically copy data from Amazon RDS to Amazon S3. Create an AWS glue crawler. Use Amazon Athena to query the data. Use S3 policies to limit access. Option C. Create a data lake by using AWS Lake Formation. Create an AWS Glue JDBC connection to Amazon RDS. Register the S3 bucket in Lake Formation. Use Lake Formation access controls to limit access. Option D. Create an Amazon Redshift cluster. Schedule an AWS Lambda function to periodically copy data from Amazon S3 and Amazon RDS to Amazon Redshift. Use Amazon Redshift access controls to limit access. The correct answer is C. Create a data lake by using AWS Lake Formation. Create an AWS Glue JDBC connection to Amazon RDS. Register the S3 bucket in Lake Formation. Use Lake Formation access controls to limit access. Explanation. Lake Formation supports unified, fine-grained access control across RDS and S3 with minimal operational overhead. Why not option A? Migrate to RDS only. Not scalable or efficient for analytics, mixes operational and analytical use. Why not option B? Lambda copy plus glue plus S3, manual process and lacks centralized access control. Why not option D? Redshift, adds complexity and cost and not ideal for fine-grained access across multiple sources. Question 104. A company hosts a marketing website in an on-premises data center. The website consists of static documents and runs on a single server. An administrator updates the website content infrequently and uses an SFTP client to upload new documents. The company decides to host its website on AWS and to use Amazon CloudFront. The company's solutions architect creates a CloudFront distribution. The solutions architect must design the most cost-effective and resilient architecture for website hosting to serve as the CloudFront origin. Option A. Create a virtual server by using Amazon Lightsail. Configure the web server in the Lightsail instance. Upload website content by using an SFTP client. Option B. Create an AWS auto-scaling group for Amazon EC2 instances. Use an application load balancer. Upload website content by using an SFTP client. Option C. Create a private Amazon S3 bucket. Use an S3 bucket policy to allow access from a CloudFront Origin Access Identity, OE. Upload website content by using the AWS CLI. Option D. Create a public Amazon S3 bucket. Configure AWS Transfer for SFTP. Configure the S3 bucket for website hosting. Upload website content by using the SFTP client. The correct answer is C. Create a private Amazon S3 bucket. Use an S3 bucket policy to allow access from a Cloud Front Origin Access Identity, OE. Upload website content by using the AWS CLI. Explanation. A private S3 bucket with OAI provides security, high availability, and low cost while serving static content. Why not option A? Light sale. Adds unnecessary cost and lacks S3 level durability. Why not option B? EC2 plus ALB. Too complex and expensive for a static site. Why not option D? Public bucket plus transfer. Public access is less secure, unnecessary for simple hosting. Question 105. A company wants to manage Amazon Machine Images, AMI. The company currently copies AMIs to the same AWS region where the AMIs were created. The company needs to design an application that captures AWS API calls and sends alerts whenever the Amazon EC2 Create Image API operation is called within the company's account. Which solution will meet these requirements with the least operational overhead? Option A. Create an AWS Lambda function to query AWS CloudTrail logs and to send an alert when a Create Image API call is detected. Option B. Configure AWS CloudTrail with an Amazon Simple Notification Service, Amazon SNS, notification that occurs when updated logs are sent to Amazon S3. Use Amazon Athena to create a new table and to query on Create Image when an API call is detected. Option C. Create an Amazon Event Bridge, Amazon CloudWatch Events, rule for the Create Image API call. Configure the target as an Amazon Simple Notification Service, Amazon SNS, topic to send an alert when a Create Image API call is detected. Option D. Configure an Amazon Simple Queue Service, Amazon SQS, FIFO queue as a target for AWS CloudTrail logs. Create an AWS Lambda function to send an alert to an Amazon Simple Notification Service, Amazon SNS, topic when a Create Image API call is detected. The correct answer is C. Create an Amazon Event Bridge, Amazon CloudWatch Events, rule for the Create Image API call. Configure the target as an Amazon Simple Notification Service, Amazon SNS, topic to send an alert when a Create Image API call is detected. Explanation. Event Bridge provides near real-time event detection with minimal setup and can send alerts via SNS efficiently. Why not option A? Lambda querying CloudTrail logs, more overhead and delayed detection. Why not option B? Athena queries, involves manual querying and delayed alerts. Why not option D? SQS with Lambda, adds unnecessary components and complexity. Question 106. A solutions architect is optimizing a website for an upcoming musical event. Videos of the performances will be streamed in real time and then will be available on demand. The event is expected to attract a global online audience. Which service will improve the performance of both the real-time and on-demand streaming? Option A. Amazon CloudFront. Option B. AWS Global Accelerator. Option C. Amazon Route 53. Option D. Amazon S3 Transfer Acceleration. The correct answer is A. Amazon CloudFront. Explanation. CloudFront accelerates the delivery of both real-time and on-demand video by caching content at edge locations globally. Why not option B? AWS Global Accelerator primarily improves TCP/UDP traffic for static IPs, not optimized for video streaming. Why not option C? Amazon Route 53 provides DNS routing but not content delivery or caching. Why not option D? Amazon S3 transfer acceleration optimizes uploads to S3, not streaming or content delivery. Question 107. A company is running a publicly accessible serverless application that uses Amazon API Gateway and AWS Lambda. The application's traffic recently spiked due to fraudulent requests from botnets. Which steps should a solutions architect take to block requests from unauthorized users? Choose 2. Option A. Create a usage plan with an API key that is shared with genuine users only. Option B. Integrate logic within the Lambda function to ignore the requests from fraudulent IP addresses. Option C. Implement an AWS WAF rule to target malicious requests and trigger actions to filter them out. Option D. Convert the existing public API to a private API. Update the DNS records to redirect users to the new API endpoint. Option E. Create an IAM role for each user attempting to access the API. A user will assume the role when making the API call. The correct answers are A and C. Option A. Create a usage plan with an API key that is shared with genuine users only. Option C. Implement an AWS WAF rule to target malicious requests and trigger actions to filter them out. Explanation. Using an API key limits access to genuine users, and AWS WAF provides automated protection against malicious traffic. Why not option B? Integrate logic within the Lambda function. This adds operational overhead and only handles requests after they arrive. Why not option D? Convert to a private API. This would restrict all public access, including legitimate users. Why not option E? Create an IAM role per user impractical and not scalable for public applications. Question 108. A company hosts a data lake on AWS. The data lake consists of data in Amazon S3 and Amazon RDS for PostgreSQL. The company needs a reporting solution that provides data visualization and includes all the data sources within the data lake. Only the company's management team should have full access to all the visualizations. The rest of the company should have only limited access. Which solution will meet these requirements? Option A. Create an analysis in Amazon QuickSight. Connect all the data sources and create new datasets. Publish dashboards to visualize the data. Share the dashboards with the appropriate IAM roles. Option B. Create an analysis in Amazon QuickSight. Connect all the data sources and create new datasets. Publish dashboards to visualize the data. Share the dashboards with the appropriate users and groups. Option C. Create an AWS Glue table and crawler for the data in Amazon S3. Create an AWS Glue extract, transform and load ETL job to produce reports. Publish the reports to Amazon S3. Use S3 bucket policies to limit access to the reports. Option D. Create an AWS Glue table and crawler for the data in Amazon S3. Use Amazon Athena federated query to access data within Amazon RDS for PostgreSQL. Generate reports by using Amazon Athena. Publish the reports to Amazon S3. Use S3 bucket policies to limit access to the reports. The correct answer is B. Create an analysis in Amazon QuickSight. Connect all the data sources and create new datasets. Publish dashboards to visualize the data. Share the dashboards with the appropriate users and groups. Explanation. QuickSight provides native data visualization and access controls for sharing dashboards with selected users or groups. Why not option A? Share dashboards with IAM roles. IAM roles are not used to share dashboards directly in QuickSight. Why not option C? Glue plus S3 reports produces static reports, not interactive dashboards or role-based access control. Why not option D? Athena plus S3 again results in static reports and not dynamic visualizations with granular sharing. Question 109. An e-commerce company hosts its analytics application in the AWS cloud. The application generates about 300 MB of data each month. The data is stored in JSON format. The company is evaluating a disaster recovery solution to back up the data. The data must be accessible in milliseconds if it is needed, and the data must be kept for 30 days. Which solution meets these requirements most cost-effectively? Option A, Amazon Open Search Service, Amazon Elasticsearch Service. Option B, Amazon S3 Glacier. Option C, Amazon S3 Standard. Option D, Amazon RDS for PostgreSQL. The correct answer is C, Amazon S3 Standard. Explanation: S3 Standard provides low-latency access with high durability and is cost-effective for small datasets with short-term access requirements. Why not option A? Open Search Service intended for search and analytics, not backup. Why not option B? S3 Glacier not suitable for millisecond access times. Why not option D? RDS for PostgreSQL overkill and more costly for storing static JSON backup data. Question 110. A company has a small Python application that processes JSON documents and outputs the results to an on-premises SQL database. The application runs thousands of times each day. The company wants to move the application to the AWS cloud. The company needs a highly available solution that maximizes scalability and minimizes operational overhead. Which solution will meet these requirements? Option A. Place the JSON documents in an Amazon S3 bucket. Run the Python code on multiple Amazon EC2 instances to process the documents. Store the results in an Amazon Aurora DB cluster. Option B. Place the JSON documents in an Amazon S3 bucket. Create an AWS Lambda function that runs the Python code to process the documents as they arrive in the S3 bucket. Store the results in an Amazon Aurora DB cluster. Option C. Place the JSON documents in an Amazon Elastic Block Store, Amazon EBS volume. Use the EBS multi-attach feature to attach the volume to multiple Amazon EC2 instances. Run the Python code on the EC2 instances to process the documents. Store the results on an Amazon RDS DB instance. Option D. Place the JSON documents in an Amazon Simple Queue service, Amazon SQS, queue as messages. Deploy the Python code as a container on an Amazon Elastic Container Service, Amazon ECS, cluster that is configured with the Amazon EC2 launch type. Use the container to process the SQS messages. Store the results on an Amazon RDS DB instance. The correct answer is B. Place the JSON documents in an Amazon S3 bucket. Create an AWS Lambda function that runs the Python code to process the documents as they arrive in the S3 bucket. Store the results in an Amazon Aurora DB cluster. Explanation: Lambda enables automatic, serverless, and scalable execution of the Python function with minimal overhead. Why not option A? EC2-based solution higher operational overhead than serverless. Why not option C? EBS multi-attach limited in practical use and doesn't scale well. Why not option D? ECS with EC2 launch type adds unnecessary complexity and cost compared to Lambda. That completes this episode. If these practice questions helped you, follow the channel and share this video with colleagues or friends who may be preparing for the same certification. Continue with the next episode in the playlist when you're ready.